In a world where scientific theories are often accepted as irrefutable truths, it's not every day that a Hollywood actor challenges the very foundations of our understanding of the universe. Enter Terrence Howard, the charismatic star known for his roles in blockbuster films and critically acclaimed TV series. But beyond the glitz and glamour of his acting career, Howard harbors a deep fascination with the mysteries of existence, and he's not afraid to question the status quo. What if everything we know about the origin of the universe is wrong? What if the Big Bang, the cornerstone of modern cosmology, is just a piece of a much larger and more complex puzzle? Howard's provocative statements declaring that time has no beginning and dismissing the Big Bang theory have sparked curiosity and controversy alike. Is he onto something that mainstream science has overlooked, or is this a case of an artist venturing too far into the realm of the unknown? The James Webb Space Telescope, or JWST, has provided new evidence that challenges the validity of the Big Bang theory. The Big Bang theory suggests that the universe started from a hot, dense state and has been expanding for over 13.8 billion years. However, recent images from the JWST have sparked significant debate among scientists. One of the most interesting aspects of these findings is the support from Terrance Howard, a well-known British physicist who has long questioned traditional ideas about the universe's beginning. This makes us wonder, if the Big Bang theory is flawed, what are the new ideas about the universe's origin and evolution? The JWST images have astonished both the public and the scientific community. These images show galaxies that are much smaller, smoother, and older than what the Big Bang theory would predict. According to this theory, as the universe expands, galaxies should appear larger as they move away from us due to the stretching of light. However, the JWST images show the opposite. The galaxies become smaller as the distance increases. This surprising observation has caused concern among cosmologists and astronomers. Alison Kirkpatrick, an astronomer from the University of Kansas, is one such expert who is rethinking her previous work in light of these new findings. The problem lies in the characteristics of the galaxies captured by the JWST. They appear unusually small and smooth, which contradicts the expectations of the Big Bang theory. The galaxies shown by the JWST are not only smaller, but also have higher redshifts than what has previously been observed by the Hubble Space Telescope. Redshift is a measure of how much light from an object in space has stretched as it moves away from us. Higher redshifts imply that these galaxies are moving away faster than what the Big Bang theory would suggest. This challenges the idea of an expanding universe. The presence of these small and smooth galaxies undermines the idea of a cosmic expansion. If the Big Bang theory were correct, these distant galaxies would need to be exceptionally tiny to fit into this model. However, this seems implausible given the new observations. The fact that these galaxies appear smaller and older suggests that our understanding of the universe's expansion might be wrong. Supporters of the Big Bang theory have long known that their model requires the existence of small, dense galaxies, sometimes referred to as mighty mouse galaxies. However, the JWST images show that even the most massive and bright galaxies are 2 to 3 times smaller than previously thought. This significant discrepancy raises questions about the accuracy of the Big Bang theory. The JWST has provided images that challenge the long-held belief in the Big Bang theory. The appearance of unusually small, smooth, and old galaxies suggests that the universe might not be expanding in the way we thought. These findings have led to a major upheaval in the scientific community, prompting experts to reconsider their theories about the origin and evolution of the universe. The James Webb Space Telescope has taken images of small galaxies called mighty mouse galaxies, which were first observed by the Hubble Space Telescope. Scientists once thought that these tiny galaxies could grow into larger galaxies through collisions and expansion. However, the new images from the JWST have shown that this is not the case. Instead of finding galaxies that look chaotic and messy from collisions, the JWST found well-formed spiral structures and smooth disks, similar to the galaxies we see today. This means that these small galaxies cannot grow to be 100 times larger through collisions. This discovery suggests that these galaxies were never small to begin with. This finding is important because it challenges the idea that the universe is expanding, a key part of the Big Bang theory. The theory predicts that the universe started from a single point and has been expanding ever since. If the universe is not expanding, this would also mean that the Big Bang might not have happened. Additionally, the JWST images show many galaxies that are very old and abundant, which also poses problems for the Big Bang theory. Using special infrared filters, the JWST can capture the colors of distant galaxies. This helps astronomers estimate the age of the stars within those galaxies. According to the Big Bang theory, these far-off galaxies should represent a time about 400 to 500 million years after the Big Bang. However, some of these galaxies contain stars that are over 1 billion years old. This contradicts the idea that nothing existed before the Big Bang. Moreover, scientists expected that the deeper the JWST looked into space, and thus further back in time, there would be fewer galaxies. They also thought they would eventually find a dark age when no galaxies existed. But the JWST images show galaxies as large as the Milky Way, even just a few 100 million years after the supposed Big Bang. Furthermore, the number of galaxies observed at very high redshifts, which indicate great distances and thus old age, is at least 100,000 times greater than what theorists predicted. It seems impossible for so many large galaxies to have formed in such a short period, challenging the Big Bang theory once again. These surprising findings have led some scientists and even Terrance to question the concept of time itself. They argue that time might just be a way humans distinguish between now and the past. Some propose that time is an illusion created by human memories, and that everything that has ever happened or will ever happen is happening simultaneously. This idea challenges the traditional view that time moves in a strict forward direction. The discoveries made by the JWST are making scientists rethink many long-held beliefs about the universe. The well-formed structures of the tiny galaxies and the existence of very old galaxies challenge the idea of an expanding universe and the Big Bang theory. Moreover, the abundance of galaxies found deep in space and the questioning of the nature of time itself show that our understanding of the universe is still evolving. These new insights remind us that in science, what we once thought we knew can always change with new evidence. The Big Crunch theory is an idea about what might happen to our universe in the distant future. Right now, we know that the universe is expanding, meaning that galaxies and stars are moving away from each other. However, the Big Crunch theory suggests that at some point this expansion might stop. Instead of continuing to spread out, the universe could start contracting or getting smaller. This means everything would move back towards a central point. If this contraction happens, some scientists believe that time might reverse. Instead of moving forward as it does now, time could start moving backward. This would mean that the processes we see happening since the Big Bang, like the universe cooling and expanding, would also reverse. Eventually, if the universe continues to contract, it would collapse into a single point, similar to how it started with the Big Bang. What happens after this collapse is uncertain and has led to various theories. Some scientists think that after the universe collapses, there could be another Big Bang, starting the universe anew. Others think the universe might just cease to exist. One idea is that this cycle of expanding and contracting could repeat multiple times, creating new universes each time. This concept of a cyclical universe means that the universe has no true beginning or end, but is constantly renewing itself. The debate about the direction of time and what it means for our universe is ongoing. Some scientists question the fundamental nature of time itself. One idea is the block universe concept, supported by Albert Einstein's theory of relativity. According to this theory, space and time are interconnected in what is known as space-time. In this view, the universe is a four-dimensional structure where every event has its place in space-time. This means that the past, present, and future events all exist simultaneously in this structure. Physicist Max Tegmark from the Massachusetts Institute of Technology, or MIT, has explored this idea further. He suggests that reality can be seen in two ways, either as a three-dimensional space where events happen over time, or as a four-dimensional space where nothing changes. If the latter is true, it means everything that has happened, is happening, or will happen already exists. We just have the illusion that time is moving forward because we perceive change. Julian Barbour, a British physicist, has also written extensively about the nature of time. He describes our experiences as a series of moments, and we are only aware of our current brain state. Our sense of the past comes from our brain storing memories. Barbour refers to a theory where each moment in spacetime, which he calls Platonia, represents a now. He suggests that our belief in the past is just an illusion created by our brains. This brings us back to Albert Einstein's theory of spacetime, which has caused a lot of discussion and sometimes confusion in the field of physics. Some scientists wonder what would happen if Einstein's theory were proven incorrect. Would abandoning the idea of spacetime help us better understand the universe? Throughout history, scientific revolutions have often led to significant progress. When scientists become dissatisfied with current theories, they develop new ones to replace the old. This pattern has happened many times in astronomy and physics. For example, for over 1,000 years, people believed that Earth was the center of the solar system. But then, Nicolaus Copernicus proposed a simpler idea. The Earth is just another planet orbiting the Sun. Despite initial resistance, this heliocentric model gained support with the advent of telescopes, and Isaac Newton's laws of motion and gravity further confirmed it. The Big Crunch theory and the nature of time are subjects of intense debate and study among scientists. Whether the universe will end in collapse and start anew, or whether time itself is an illusion, these questions drive our understanding of the cosmos. Just as past scientific revolutions have reshaped our view of the universe, future discoveries may change how we perceive time and existence itself. Isaac Newton was a brilliant scientist who helped us understand how gravity works. He explained that the sun's gravitational force causes the planets to orbit around it. Newton said that objects with mass like the Earth and the Moon pull on each other with gravity. This is why the Earth orbits the Sun and the Moon orbits the Earth. Newton's ideas about gravity were accepted for almost 300 years. Then in 1915, another great scientist named Albert Einstein introduced a new way to understand gravity with his general theory of relativity. Einstein's theory helped solve some problems that Newton's theory couldn't explain, like the strange way Mercury orbits the Sun. Einstein's theory was proven in 1919 during a solar eclipse off the coast of Africa. Unlike Newton, who thought of gravity as a force pulling objects together, Einstein saw gravity as a result of the bending of space. He said that the universe is like a huge four-dimensional fabric called space-time. When large objects like the Sun are in this fabric, they make it curve. This curvature is what causes planets to move in their orbits. To us, this bending looks like a pull of gravity that Newton described. Einstein's idea of space-time and how it blends has been the most accepted theory for over 100 years. It's been so successful that it even overshadowed other theories. In 2015, scientists discovered gravitational waves, which are ripples in space-time. This discovery was a big deal because it further confirmed Einstein's theory. However, even though Einstein's theory is very strong, it might face new challenges. This is because it doesn't match well with other important theories in physics called quantum theory. Scientists are still working on how to bring these two theories together to get a complete understanding of how the universe works. The quantum world is pretty strange. Imagine particles being in multiple places at once. Back in the 1930s, there was this intelligent man named Erwin Schrödinger, who came up with a weird idea called quantum superposition. He used a funny example called Schrödinger's cat. Picture this, a cat in a box with a vial of poison. If a quantum measurement happens, a hammer might smash the vial. According to quantum physics, until someone looks in the box, the cat is both alive and dead. Crazy, right? But here's the thing, this idea clashes with another big concept called space-time. Einstein talked about this. He said space-time is like a smooth fabric, and gravity is part of it. But in quantum physics, particles can be in different places at once, which doesn't fit with this smooth fabric idea. According to Einstein's theory, gravity can't be in two places at once. It's affected by stuff like matter and energy, and it curves space-time. But quantum physics says matter and energy can be in different states at the same time, messing with this idea of smooth space-time. So, where does gravity hang out? Howard says there's no good answer for that. It's like trying to fit a square peg in a round hole. This is a big problem in physics right now. When scientists try to put together Einstein's ideas with quantum physics, they get stuck. The math just doesn't work out. Sometimes it gives answers that don't make sense, like probabilities greater than 1 or even infinity. So these two theories just don't get along. It's like they're enemies, and scientists are trying to make them be friends. They want to find a way for quantum physics and Einstein's ideas to work together nicely. This is called the unified theory of quantum gravity. String theory is one of the most famous proposals in the quest to understand the universe. It often is considered a bit outlandish. Imagine this. Instead of tiny balls, it suggests that tiny vibrating strings make up super tiny things like electrons and quarks, which are even smaller than atoms. String theorists believe that different combinations of these vibrating strings create different particles. What makes string theory exciting is that it could help bring together two big theories in physics: general relativity, which talks about big things like planets and stars, and quantum physics, which deals with super tiny things. But here's the kicker. For this theory to work, these strings must vibrate across 11 dimensions. That's 7 more dimensions than the ones we usually think about in Einstein's space-time fabric. Now, here's where it gets even more tricky. Right now, there's no real proof that these extra dimensions even exist. So we can't be totally sure if it's how our universe really works without doing some experiments. That's where scientists like Jorma Luca at the University of Nottingham come in. They're trying to figure out if string theory is the real deal or just a cool idea. But because there's no solid evidence yet, some physicists are looking at other ways to explain how the universe works. One alternative they're exploring is called loop quantum gravity, or LQG for short. Now, LQG is a bit different from string theory. Instead of tiny strings, it's all about loops. Imagine a rubber band. If you make a loop with that, that's kind of what LQG is talking about. It suggests that space itself is made up of these tiny loops. One of the cool things about LQG is that it doesn't need extra dimensions to make sense. It works within the 4 dimensions we already know about: up, down, left, right, forward, backward, and time. So, in a way, it's simpler than string theory because it doesn't need to add extra dimensions to the mix. But just like with string theory, there's still a lot we don't know about LQG. Scientists are still trying to figure out if it's the right way to explain how the universe works. They're doing experiments and studying math to see if LQG can explain things like gravity and the behavior of particles. Loop quantum gravity and string theory propose new ideas about space-time. While general relativity sees space-time as a smooth fabric, loop quantum gravity suggests it's made of tiny loops. It's like a close-up of a cloth, revealing stitches, or zooming in on a digital image to see individual pixels. The challenge with loop quantum gravity is how incredibly tiny these loops are. We're talking about things that are so small, like a trillionth of a trillionth of a trillionth of a meter. That's beyond microscopic. These tiny defects in space-time would only be visible at what's called the Planck scale. At this scale, the number of loops in even a small space would outnumber all the space in the observable universe. Now, testing these ideas is tough. To explore the Planck scale, we'd need a particle accelerator 1,000 trillion times more powerful than the Large Hadron Collider, or LHC, at CERN. And this accelerator would have to be as big as our entire Milky Way galaxy. That's mind-blowingly huge. But here's where things get even more interesting. A group of physicists from the UK, France, and Hong Kong have come up with a different plan. They want to use something called an ultra-cold gas containing billions of cesium atoms in a state called a Bose-Einstein condensate. Now, what's that? Imagine all these atoms getting so cold that they just start acting like one big atom. By studying how this ultra-cold gas behaves, these physicists hope to find clues about space-time at the tiniest scales. It's kind of like detectives looking for clues at a crime scene, but instead of fingerprints, they're searching for tiny ripples and vibrations that could tell us more about the fabric of the universe itself. Bose-Einstein condensate is being used to see if gravity acts like a quantum force. Meanwhile, scientists are also looking at space itself to find tiny defects in space-time. Light from far away in the universe has traveled billions of years to reach us, even though each defect might not do much. If lots of them add up, they might have an effect we can see. Astronomers have been studying light from big explosions in space called gamma-ray bursts for clues about these defects. But there's a problem. The light from these explosions sometimes looks weird. Some scientists think maybe it's because of these space-time defects. Others aren't so sure. They think maybe something else is causing the strange light. To figure this out, some scientists think we need to change how we think about space and time. Einstein thought space-time was like a stage where things happen. But some new scientists say space-time doesn't exist on its own. They think space-time is made by the things in it. It's like saying the dance floor only exists when people are dancing on it. This idea might seem strange, but some scientists think it could solve a big problem. You see, there's this thing called entanglement in quantum physics. It's like when two particles are connected, no matter how far apart they are. It's so weird that Einstein called it spooky action at a distance. The new idea about space-time might help explain entanglement. If space-time is made by the things in it, then maybe that's why particles can be connected across huge distances. It's like they're talking to each other through the space they create together. In the realm of space and time, there's something fascinating called spooky action at a distance. It's a concept where things can affect each other even when they're far apart. This idea challenges how we think about separation. Instead of physical distance, it suggests that what really matters is how things relate to each other in the quantum world. Scientists like Friedel Lee and Minnick have been studying this idea for a while now. They're trying to understand how gravity influences the quantum world. It's a bit different from other theories that focus on turning gravity into quantum stuff. They're taking it slow, step by step, but they're excited about where their research might lead. Now, you might be thinking, why should I care about this? Well, here's the thing. Our whole world is connected to space-time. If we change how we understand space-time, it could affect everything from how we think about gravity to how our gadgets work. Think about your phone or computer. They work because of something called quantum theory. If we learn more about how space and time work on a quantum level, it could lead to new and better technologies in the future. Maybe we'll have gadgets we can't even imagine right now. All this stuff might not happen right away. It could take years, even centuries, before we see the full effects of these ideas. So, while scientists are busy exploring spooky action at a distance and other cool theories like string theory and loop quantum gravity, they're also thinking about what comes next. There are lots of ideas out there, from casual dynamical triangulation to non-commutative geometry, all trying to shed light on the mysteries of space and time. Casual dynamical triangulation, or CTD, is a way of looking at gravity that breaks space-time down into triangles. Instead of thinking of gravity as a powerful force that pulls things together, some scientists think of it as something that happens because of other tiny things interacting. This idea is called emergent gravity. Asymptotic safety is another way of thinking about gravity. Instead of getting wild and out of control at high energies like we might expect, gravity stays predictable and well-behaved. Non-commutative geometry is a bit like saying that space and time don't always follow the rules we expect. Instead of playing by the usual rules, they have their own special way of doing things. As we journey through the cosmos and Terrance Howard's thoughts, we find ourselves standing at the intersection of science and philosophy, art and inquiry. His bold statements about time and the Big Bang may be met with skepticism by the scientific community, but they also serve as a reminder that questioning the established order is a fundamental part of human progress. Whether you find yourself agreeing with Howard's theories or firmly rooted in established science,
there is enough electricity to create a second sun. Light would appear around the equator, like a ring around Saturn. Humanity is not prepared for greatness. I've spent years looking for ways that this energy could influence people.
Nikola Tesla, born on July 10, 1856 in Smiljan, Croatia, then part of the Austrian Empire, was a Serbian-American inventor, electrical engineer, mechanical engineer, and futurist. Renowned for his groundbreaking contributions to the development of alternating current, AC, electrical systems.
The beauty and aroma of the roses can be used as a medicine and the sun's rays as food. Life has an infinite number of forms, and the duty of scientists is to find them in all forms of matter.
Tesla displayed an extraordinary aptitude for science and mathematics from an early age. After studying engineering and physics in Austria and Bohemia, he worked in the burgeoning electrical industry in Europe. In 1884, he immigrated to the United States, where he briefly worked with Thomas Edison before striking out on his own.
3 things are essential in this regard. All I do is look for them. I know I will not find them, but I will not give them up. It is another thing to destroy the power of evil and the suffering in which man's life passes. Sometimes they occur as an epidemic in the depths of space. In this century, the disease had spread from Earth to the universe.
One of Tesla's most significant achievements was the development and promotion of AC electricity, which he believed was superior to Edison's direct current DC system. His work on AC power included the invention of the Tesla coil, an essential component in many modern electronic devices.
I know that gravity is adverse to everything I have to fly, and my intention is not to make flight devices, aircraft, or missiles, but to teach the individual to regain consciousness of their own wings. I'm also trying to awaken contained energy in the air. There are major energy sources. What is considered as empty space is only a manifestation of matter that is not awake. There is no empty space on this planet, nor in the universe. Black holes, of which astronomers speak, are the most powerful sources of energy and life.
Nikola Tesla was known for his eccentric personality and flamboyant public demonstrations of his inventions. Despite his numerous patents and the transformative nature of his work, he struggled financially throughout his life and was often overshadowed by his contemporaries like Edison and Marconi. And Tesla is celebrated as a pioneering genius who was ahead of his time. His contributions to electrical engineering, particularly his development of AC power systems, have had a lasting impact on the modern world.
We've been misled just because we've been fooled by our senses. Our eyes see 0.05% of the entire electromagnetic wave. We're blind cosmically, but we judge everything by what we see. And they've done that with science for so many years. You look at E equals MC squared, that talks about expansion. It does not show how it's divided. You've never breathed in twice without breathing out. You breathe in and you breathe out. You charge and you discharge.
I've spent 45 years searching these things out and trying to figure out what the universe how it really worked. And we've come to find that the universe, they are abandoning the standard model, the ideas of black holes and dark matter, for an electric model of the universe that is in response to the Berkeley currents and all these things. It's a better version, a better vision of how we should see the universe. That's how I see it, and I think it should be explored.
Religions and philosophies teach that man can become the Christ, Buddha. What I am trying to prove is revolutionary and almost inaccessible. It is what must be done in the universe so that each being is born as Christ, Buddha, or Zarathustra. There are 4 laws of creation. The first is that the mind cannot conceive or mathematically measure the source of the whole bewildering and dark plot, and that plot fits the whole universe. The second law resides in expansive darkness, which is the true nature of light, of the inexplicable, and is transformed into light. The third law is the need for light to become a matter of light. The fourth law is there is no beginning or end.
We know that energy does not die. Energy just reboots itself and reboots itself. So we are eternal. So stop panicking, thinking your life is over. You've done this trillions of times. You'll get good at it and we'll be perfect one time if we get conscious. And what I tried to tell you guys earlier, this is not your first time, it's not your first rodeo, and it won't be your last rodeo. Don't panic in this life. You can actually, there's no sense of death. Everything goes to sleep and it wakes back up again.
There is no death. There's no death. Everything's eternal. And once we get rid of the idea, okay, you're gonna die and disappear, then they don't have any grasp over you anymore. And to be free, the truth will set you free. That's why I was like, okay, well, if this truth cost me this lifetime, then wonderful. I've accomplished what I needed to do.
I knew from my childhood that I would get most of my discoveries, although I was not entirely clear.
Well, it's been 40 years of me dancing on this thing. For 40 years, I was told I was wrong. For 40 years, I was told that, the platonic solids and all those were the solids. You have to have faith in self. All of this, I can sit up here and tell you guys that, I'm the smartest man in the world. I figured out what Da Vinci and none of them could do. The truth is, you really want to know the truth? This may be crazier than the fiction. The truth is, I woke up inside my mother's womb at about 6 months of age. I woke up inside of there. Like boom. I don't know what had happened. Maybe my mother went through some trauma or whatever. But I woke up and I was like, oh God, I'm here. I'm here. Don't forget, don't forget, don't forget, don't forget, don't forget. This is truth. Don't forget, don't forget, don't forget. So what I'm saying to you, you are conscious inside the womb, but we have no common frame of reference. But I remembered, don't forget, don't forget, don't forget, because I knew I'd been here. Don't forget. And you know what I didn't want to forget? This flower of life. Because apparently I'd been interested in it at a given time. And I came out and I was born. The first thing I thought about when I was 5 years old, I was obsessed with bubbles. I was like, why does a bubble take the shape of a ball? Why not a square or a triangle? And I would go and try and make square or triangular bubbles. And we could never do it because it turns out everything expands as a sphere and everything contracts in geometric form.
First, a maintenance of the whole. The body of man is a perfect machine. I know my circuit and what is good for it. Food that almost all people eat, to me, is harmful and dangerous. Sometimes I visualize cooks of the world being all conspiring against my note.
When you speak against the established norm, you get pushed outside. You don't get funding anymore. I've invented, here I'm an Oscar-nominated actor that is known all around the world, face recognition, vocal recognition, all around the world. I've invented a new form of flight, tangential flight, the ability to fly around your own center of mass, something they've never been able to do. And you don't hear anything about it.
Tesla credited his many inventions to the ability to realize them entirely in his mind. He also described experiencing intense flashes of light, which were followed by moments of intense creativity and clarity.
He would see an invention appear before his eyes in almost holographic detail. He said that he could rotate these visions, take them apart, piece by piece, and he knew exactly how he was going to build these inventions based on his visionary experiences.
I'm going to have to thank the visualization for everything I've invented. The events of my life and my inventions are real in front of my eyes, like any occurrence or article. In my youth, I was afraid of not knowing what it is, but later I learned to use this power as an exceptional talent and a gift. He nourished and projected jealousy. I also did the corrections through visualization in most of my inventions and ended them that way. By visualizing mentally, I solved complex mathematical equations. For that gift I have, I will receive the distinction of the High Lama in Tibet. My sight and hearing are perfect, and dare I say that they are stronger than in others. I hear the thunder 150 kilometers away, and I see colors in the sky that others cannot see. This expansion of vision and hearing I have had since I was a child. Later, I developed it consciously. Life is a rhythm that must be understood. I feel the rhythm. I let it lead and I consent. It was very nice and gave me the knowledge I have. All that lives is in a deep and wonderful relationship. The man and the stars, the amoebas and the sun, the heart and the circulation of an infinite number of worlds. These ties are unbreakable, but can be tamed, propitiate, and begin to create new and different relationships in the world, and not violate the old. Knowledge comes from space. Our vision is the perfect set. We have two eyes, the earthly and the spiritual. It is recommended that they become an eye. The universe is alive in all its manifestations. like a thinking animal. The stone is a thinking and sensitive being, such as plants, beasts, and a man. A star that shines has to be seen, and if we are not self-absorbed, we would understand its language and its message. The breath, the eyes, and the ears of man have to fulfill the breath, the eyes, and the ears of the universe.
Perfect resonance, because we are all connected on this ether, and that waveform that's the consciousness. We are all just one great being.
Yeah.
You know, that's what they forget. We're not separate. The universe is probably one cell inside of some super organism.
Right.
Everything has an equal and opposite. It has to mate. Mating is a big part of what we do. The boron mates with nitrogen, and that's how the carbon happens. Everything inside of us, all our cells, they're mating. There's a relationship going on in it. Everything's alive.
Knowledge of how to transform mental and vital energy into what we want and achieve control of all feelings. Hindus call it Kundalini Yoga. This knowledge can be learned for what is needed many years, or can also be acquired by birth. Most of them I have acquired by birth. They are in the closest relationship with sexual energy, which is one of the most widespread in the universe. The woman is the greatest thief of that energy, and therefore of spiritual power. I have always known, and for this reason I have been alert. From myself, I have created what I wanted, a reflective and spiritual machine.
I didn't come into this world the way everybody else does, I don't think.
It means that there is a general knowledge and that there is the truth that man has always possessed. In my feeling and experience, the universe has a single substance and a supreme energy with an infinite number of the manifestations of life. The best thing is that the discovery of one secret nature reveals the other. They cannot be hidden. There are those around us, but we are blind and deaf to them. If we emotionally bind them, they come to us. There are a lot of apples, but only a Newton. He needed only one apple that fell in front of him.
How the universe behaves. It comes in and it goes out. When Newton said that gravity pulls down, if he had with that apple, yes, the apple was attracted to like conditions on the earth. It was attracted to like conditions. If he had spent another week or 2 weeks watching that apple, he would have watched the gases go right back up to where they were equalized. Everything, if it comes this way, it has to go this way. You breathe in, you breathe out. It's filling in or pouring out.
The body of a man and the brain are made of a lot of energy. In me, there is most of the electricity. The energy, which is different in each person, is what makes the human I, or soul. For other creatures, in their essence, the soul of the plant is the soul of minerals and animals. Brain function and death are manifested in the light. My eyes in youth were black. Now they are blue, and with the passage of time, as the tension of the brain becomes stronger, they will be closer to the target. What is the color of the sky?
Gravity is supposed to be the greater the mass is the greater the attractor. You take a balloon, you rub it on your leg, you put it over the ground. Watch the dust particles jump off the ground, off this big mass called the Earth, and jump onto that balloon. Because why? Electricity is 137 times stronger than the pull of gravity or the effects of the so-called gravity. It's the electric force that's the attractive force. It's the electric force that tightens everything together as the masculine, and then the dividing force is the radiative force, the magnetic field. It oblates and pushes everything out, and then they collect together again. But where these things meet, at the proper angles of incidence, like the Birkeland currents talked about, those plasma currents talked about, those angles of incidence is at 120 degrees when it converts it back into electricity, and it will keep collecting and coming and making life. The planet isn't a dead thing. It didn't just happen to come together. That's just the process by which it was given life. It's alive, and it's screaming. It thought we were going to be beneficial to it.
Everything is light, and one of its rays is the fate of nations. Each nation has its own ray in that great source of light that we see, that is the sun. And remember that there is no man that has existed and has not died. It became light and as such still exists. The secret lies in the fact that the particles of light restored their original state.
Engineering the first year over at Pratt, and they, at the time, I think it was like 108 elements, and I told the teacher, the professor, about the relationship between hydrogen on the spectrometer and carbon and silicon and cobalt, and it was like it's the same exact color, same tone, just doubled in each octave. And he was like, no, each element is the same element and it will always be that element. And I was like, you don't see the relationship. So Einstein left that out of his equation because he coupled electricity and magnetism together and didn't realize that electricity was the equal and opposite of magnetism. Electricity being the contractive field. You breathe in, that's a contractive thing. You breathe out, that's a magnetic thing, a radiative thing. But they use the term magnet as an attractor. But to magnify something means to what? Make it larger, increase the space. That's the work of radiation. That's what Walter Russell was talking about all those years. They're acting as if the universe is just expanding out, breathing out, and it's going to dissipate out, and they never include the contractive side of it, breathing in. Honest, life is about the give and take. There's a balance in there, you know. You picture dropping a pebble into a pond or a pool. Everything expands in these longitudinal waves, right? Perfect spheres, unless there's something else in there. But when it hits the edge, it all starts bouncing its way back. And when these returning waves meet expanding waves, that's when we get our first geometry. So this is the proof that the universe is not infinite, but finite. Because you could not have shape without the returning waves, and the waves would not return unless it was bouncing off of the edge of something.
Look how...
With electricity, you could send 1,000 volts or 1,000,000 volts through the same aperture. And that water is incompressible. And so it's just going to react, and immediately it converts into a plasma. And so we can project anything into space. All of that has been accomplished, and it's ignored. It's the end of Planck. It's the end of Schrodinger's equation. It's the end of Heisenberg's uncertainty principle. And I'm ready to have the debate at any university, anytime they want to. But they have no comeback for it, because I have 4 supersymmetrical systems, and that's the thing about geometry. Geometry is its own proof. Supersymmetry is its own proof, whereas equations, anybody can have an equation. And only certain people can try and understand it, and it can be fudged with renormalization, where anytime they have an infinity, they renormalize it. That's why Dyson left the whole group back in 1940s when they were talking about quantum electrodynamics. And Feynman said it himself, with this renormalization, is that real physics? Is this real math? All of them recognize that this is fudging, because they had went the wrong direction by taking the ether out of the equation. And now I have proof of the ether and how it behaves. I have a thing called zero. They go from 1 to 0 to -1. There is no zero to even think zero.
So do you think that zero is a concept that came along with currency?
It should be attached to currency in that regard, because in physics, it's either nothing remains still. There's nothing still in the universe. There's nothing that doesn't have motion, because everything is connected. So if one thing is still, everything that's connected to it has to be still. There can never be one thing still. So as electricity tries to get to its balanced state, right when it gets there, magnetism takes over and it pushes over. So there's this pendulum, and as soon as it gets to this state, it bounces off that other noble gas, and it makes its way all the way back over here, and it's about to have equanimity, and then it gets pulled back into the other direction. And that's the breathing in and breathing out, and the pendulum effect that we've all observed in natural phenomena. in the universe. Now we write new axioms and new postulates based off the real wave conjugations. Now we adjust our understanding of our physics to fit natural phenomena. And then we are in balance with it, and we have to let go of the idea of this currency. We're the only creatures in the known universe that uses currency, that uses an indirect form of payment instead of a direct exchange. We have to get past that point, and that's the hard thing, because this entire world is run on that, and that's where the 1 × 1 = 2 came into its real birth.
You believe there's straight lines in the universe? Well, let me hit you with something. All energy in the universe is expressed in what? It's in motion. If something is still, there's no energy. Kinetic, right? All motion is expressed in what? You look at galaxies, are they expressed in straight lines? Expressed in vortices. All vortices are expressed in what? Waves. All waves are curved. Show me a straight line in nature. You show me where the platonic solids come from. Where do they have their foundations in our universe? Are there any straight lines? If you look at anything, there are no straight lines. That's been the mistake. We've been looking at these straight lines, this Euclidean way of thinking, and missing the curvature of nature.
If you looked at this, you'll say, oh, that's a square right there, right in the middle.
Sure.
You'll see that square happening right there. But if you look at it from the side, from its real perspective, you see that it's not. The straight lines are an illusion. Again, we are being fooled by our senses because there is no motion in the straight line. So all these homes that they're building, and they keep wondering, why do they keep blowing over? Why don't you make the homes look like a mushroom? Follow the curvature of nature, and you won't have to worry about rebuilding them in hurricane zones or in tornado zones. It'll go right over it.
We have changed all of our buildings to be aerodynamic. Our airplanes are no longer based on a 2-dimensional Euclidean way of life, but our math is still based on a 2-dimensional way. And I think in order for us to reach the future, we have to examine that.
The fundamentals. We're still going with Euclidean straight lines when there are none. And we would rather think we have understanding of the universe at 4% and keep the 96% as a mystery. And we invent all these science fictions, black holes and dark matter and dark energy and all of this stuff, neutron stars that's spinning so quickly. We invent all of these things because the math is off. Because the math is not based on equanimity, and they have renormalization. It's the same experience, just under a different temporal dimension. Change the pressure condition, change the motion condition, you change the organism, it adapts. But it's the same living principle. There's no difference between us and the plants. And when people are chopping down and ripping things off just because they can't hear them scream,
we're going to crash as a species because our math needs to work in order for our science and our future to develop. Well, I think we have an economic problem because we are the only creatures in this universe that use currency. There are no other creatures that use currency in order to exist. Why is it that we chose this strange thing that isn't even real? Other creatures, they drink water, they eat fruit, they eat other animals. We exchange with currency, and our system of exchanging with currency is flawed because of greed. There's not like if 1 × 1 = 2, we've got an equilibrium of balance. 1 × 1 = 1, you've got loss. When 1 × 1 = 3 or more, you're talking about over unity and supersymmetry. And that's how you get the universe to work for you. Instead of using just the solar voltaics off of it, you also use the piezoelectric effects of it. You use other things to make greater unity.